Hello everyone. I think we are ready with today's topic, recursion. So this is my favorite topic in the data structures and algorithms. So let me tell you that here, if you see in this picture, let me come from this OBS studio itself. In this picture, I have a picture of this screen, and in that I have a screen in that, and in that screen I have another screen, and so on. It is like infinite, right? So one screen is having the same screen again. Let me write it. One screen is having a screen, and that is having the same screen. In that I am having the same screen, like that. So I'm coming from the basic thing that in the same screen we are having multiple, the same screens, right? So what if I can go in reverse, right? So this screen is present in the outer screen, and this screen is present in the outer and then outermost screen, right? So what do you say this is, I can say this as a recursion, right? Let me tell you by taking an example of a problem, right? So calling the same thing again, Fibonacci number, right? Okay, let me tell you, explain you this. What is a Fibonacci number? The Fibonacci numbers, commonly denoted f of n, form a sequence called the Fibonacci sequence, such that each number is the sum of the two preceding ones, starting from 0 and 1. That is, f of 0 is equal to 0, f of 1 is equal to 1, f of n is equal to f of n minus 1 plus f of n minus 2 for n greater than 1. Given n, given n, calculate f of n. Let me tell you what they are saying us. If it is a recursion, we need to talk about the Fibonacci sequence, however. So in the Fibonacci sequence, right, we have the Fibonacci sequence, right? First, let us start f of, let me tell you, f of 0 is equal to 0 and f of 1 is equal to 1. Let me tell you that f of 0 is 0, f of 1 is 1. Now let us go with the problem n is equal to 2, and they have said that f of n is equal to f of n minus 1 plus f of n minus 2 for n greater than 1. Let me write the formula also. F of n is equal to f of n minus 1 plus f of n minus 2. Okay. Now, we are asked for f of 2. Now, f of 2 is nothing but f of 2 is nothing but f of 2 is equal to, what is f of 2 minus 1? F of 1. What is f of 2 minus 2? F of 0, right? So what is f of 1 plus f of 0? F of 1 is 1. 1 plus 0 is also 1. So we will return 1 as the output, right? So I think it's clear for you. If you have any doubts, please let me know, right? Okay. So first thing, Okay, right. So if we are asked for f of 2, we'll be returning 1 plus 0, nothing but 1. Now, let me tell you that what if we are asked for f of 3, then f of 2 plus f of 1. Let me tell you how. So, f of 3 will be f of 2 plus f of 1. Now, what will be f of 2 and f of 1? Absolutely right. 1 plus 1 will be 2 here. Now what about f of 4? 2 plus 1, 3. What about f of 5? 3 plus 2, 5. What about f of 6? 5 plus 3, 8, and so on. So this is how you get the Fibonacci sequence. Now let us write that how do I get f of instead of 6, let us take a small number, just 5. Okay, now f of 5, I need f of 4 and f of 3. Now f of 4, how do I get f of 4? I need f of 3 and f of 2, right? So if I add both of this, I'll get f of 4, right? I'm correct, right? Now, what about f of 3? I need f of 2 and also f of 1. What about f of 2? I need f of 1 and also f of 0. Is there anything which we can go further? Why? Because f of 0 is 0, f of 1 is 1, right? Let me tell you how this works. Now, f of 1, I know it. Already I knew it, right? So it is nothing but 1. What about f of 2? F of 1 plus f of 0, right? So add these two. F of 0 is 0, f of 1 is 1. Okay, f of 3. I'll start with f of 2 and f of 1. Now f of 2, f of 1 plus f of 0, right? So 0 and then 1. Here 1. Now f of 5 will call for f of 4 and f of 3. This f of 4 and f of 3, right? So this f of 4 will call for f of 3. We are discussing about Fibonacci sequence. Fibonacci number, right? Fibonacci number. Okay. So f of 4 will call for f of 3. What is the value of f of 3? And also f of 2. Okay. Now f of 3 will call for f of 2 and f of 1. For f of 1, I know it is 1. So I'll return here itself. I'll return 1 here itself. There is no going beyond 1 and 0, right? So this has called to this and also this, and f of 1 has returned 1, but f of 2, it doesn't return yet. So it will call for f of 1 and f of 0. F of 1 will return 1, f of 0 will return 0. So 1 will be returned and 0 will be returned here. 1 plus 0 is 1. 1 plus 0 is 1 here. Now here f of 1 is also 1. So what I'll do? 1 is returned and also here 1 is returned. 1 plus 1 will be 2. Now here also f of 2 is calling for f of 1 and f of 0, right? So f of 2 will call f of 1 and f of 0. F of 1 will return, f of 1 will return f of f of 1 will return 1 and f of 0 will return 0. So this will return 1 and this will return 0. So 1 plus 0 will make 1. Now 2 plus 1, 2 will be written here, 1 will be written here. So 2 plus 1 will be 3. Now this has called f of 3, right? But there is a thing that f of 3 has already been calculated. But I'll tell you why we are wasting much time, and we can optimize it by using dynamic programming, but it is not our time to go to sorry, uh, dynamic programming without understanding the recursion. So we need to understand the recursion in order to go to dynamic programming. So f of 3 will call for f of 2 and f of 1. So f of 1, I know it is 1. So it will return 1 here. Now, f of 2 will call for f of 1 and f of 0. Now, f of 1 will return 1 and f of 0 will return 0. Now, 1 is returned, 0 is returned, right? So, here it is 1 plus 0 will be 1. Now, here also it is 1. Now, 1 plus 1, here it is 2. Now, 3 plus 2 will be 5 here. F of 5 is 5. So, this is how it works. If you see, I have stopped here itself, right? I have stopped when I have f of 1 and when I have f of 0. F of 1 and f of 0. Wherever I got f of 0 and f of 1, there I have, at those places I have stopped my search, right? So let me write one thing clearly for you. The moment you want to stop, you want to stop and return, that's your base case. So the base case is nothing but the thing which we already knew or which we don't want to explore much. So here f of 0, I knew it already. F of 1, I knew it already. But what if I go beyond? We are searching for f of 5 is searching for 5 minus 1, 4, 5 minus 2, 3, n minus 1 and n minus 2, right? So 0 minus 1 is minus 1, 0 minus 2 is minus 2. Do we have any Fibonacci numbers with minus 1 and minus 2? No, we doesn't have. Why? Because the Fibonacci sequence itself starts from 0. For f of 0, it is 0. F of 1, it is 1. The moment you want to stop and return, then that's your base case in recursion. Let me write it also. Right? In, wait a second, recursion. Right? Okay. That's your base case in recursion, right? So let me know in the live chat if you have any doubts. I think it's a clear, simple problem for Fibonacci sequence, right? A simple problem. But how can I solve this? Now, Fibonacci of, let me change the color. So the first thing, Fibonacci sequence of int n, right? Okay. F of 5. 5 has called for 4 and 3. 5 is our n and 4 is n minus 1 and 3 is n minus 2. For 3, I have called for 2 and 1. For 2, 1 and 0. For 1, I knew it already. For 1, I knew it already. For 0, I knew it already. For 4, 3 and 2. For 3, 2 and 1. For 2, 1 and 0. For 2, 1 and 0. So 1 and 0, I knew it already. So I returned there itself. So, what does it mean? What we have understood from this is, firstly, we will be having n. That's what we have called for. Now, I need to return what I am returning here. What I am returning here. I am returning what I'll get for n minus 1 plus n minus 2. So, return Fibonacci of n minus 1 plus Fibonacci of n minus 2. Now, what if n is lesser than 2? What does it n is lesser than 2 mean? N is lesser than 2 means 1 and 0. So, if n is lesser than 2, what I did? 1 for 1 I returned 1, for 0 I returned 0. So, return n there itself. It's just 3 lines of code. If you see, return Fibonacci of n minus 1 plus Fibonacci of n minus 2 in Fibonacci of this. So let us do the code for this. So I think we have understood how can we go with the regression. First, if n is lesser than 2, return n, else return Fibonacci of n minus 1 plus Fibonacci of n minus 2. It is just calling the same function itself, right? So it got accepted for the 3 test cases. Yes, it got accepted. So if you see, I think it would be clear for if we go through the recursion thing, right? This tree, recursive tree. So whenever it is a recursion, we need to go with the recursion tree so that we can easily understand how it functions, what is the base case in the recursion. So the recursion itself, we need to go with the base case. We need to know what will be our base case, right? Okay, let us see, go with the next problem. We have solved the first problem, Fibonacci number. Right here, it will be a binary tree and an integer. Okay, we haven't solved the trees, right? So let us go with the reverse string and power of x comma n. And I'll be giving you 3 problems for practice, right? So reverse string. Okay, write a function that reverses a string. So write a function that reverses a string. The input string is given as an array of characters. Uh, you must do this by modifying the input array in place with big O of. Okay. If you see here, O need to be replaced with H and L need to be replaced with E and then L again. Okay. Reverse a string. So we need to do it by in place, right? So we need not to take any extra space, right? So, right? So without that means big of one extra memory is nothing but we should not create any array, additional array. That's what it means, right? Okay, okay. What I thought about this problem, what I thought about this problem is firstly, right, when we got at L, we should not do any regression, any changing, right? We need not to reverse it. What I want to do is swap n minus 1 with element at 0, right? Element at index 0. N minus 1 minus 0 and then n minus 1 minus 1. It is nothing but n minus 2, right? So that's what I thought. Okay. But when it is like in the middle, then I should not, I think. If it is lesser than, what is the size? It is 5. 5 by 2 is 2 itself, 0, 1, 2. If it is at lesser than 2, then we should not swap it, right? Okay. H-A-N-N-A-H. So even when you swap it, it will be the same. But here, if you see, H is in capitals, uppercase, sorry, and H is in lowercase. Okay. So the string length can be 10 power 5, right? Okay. So, firstly, let us take this out of this group and let us think how can we solve this problem actually, right? So what I'm thinking is n minus 1, wait a second, you have H-E-L-L-O, right? H-E-L-L-O. Now, O is nothing but n minus 1 minus 0. I'm thinking like that for some time. N minus 1 minus 0. Why? Because this 0, I kept this 0 because I can swap it with this one. Now this is n minus 1 minus 1. Why? Because I can swap with index 1. So this is index 0, 1, 2, 3, 4. What is n? N is 5, right? Okay. Now what is this 2? Let me tell you that here n minus 1 minus 2, it is nothing but 5 minus 3 is 2. And the swapping number is also swapping index is also 2, right? So if we even swap, there is no use, right? Now, if you go here and swap it again, this, let me tell you, after swapping till here, I will get L, E, H, and here I will get L and O here. So I have swapped here and then here and then here. But here, if you swap it here also, then you will get this swapped with this ELL, right? So these two are swapped. Now, if you swap this with this one, just imagine this with this one, you get HELLO, that's the same string again. So when I have to stop that, I need to stop it when I go this one. This I am indicating it as I. So if I is lesser than n by 2, then stop there itself, right? Return. Okay, let us see. Let us see how I can go. Okay, so first to call this thing, I need a function, right? Firstly, we need a function to firstly we need a function to call the recursion, right? First, I need a recursive function. Here, I will get the index, however, I, right? I will be having index I, and I'll be having the string S that I'll be changing, however. And is there anything extra? Yes, the size of the string. Okay. Now, if you see, if I is less than n by 2, I said return there itself. That means we are stopping the recursion there itself. But if not, we will be swapping s of I with s of s of n minus 1 minus I. And then is there any way can we return it? No, right? So we are just using this void. Void is nothing but which will not return anything at the end of the function. So firstly, uh, firstly, I need to call with n minus 1 minus 0. N is 5, right? Okay. N will not change, however. And then I need to call with, I need to call for a recursion of I plus and string is the same and n is also the same, right? Now I will call the recursion with I is nothing but 0. The string is a given string. N is s dot size. So n here. So I'll just call it and it will do my job. So let me write this function first. Okay. Void recur int I string s int n. If I is less than n by 2, then return there itself. Swap the characters s of I, comma s of n minus 1 minus I. Now recur I plus 1. Sorry. We are incrementing I. Instead, we can just, here we are incrementing I. Instead, we can just write I plus 1. So no need of incrementing the I pointer. So here we'll call for int n is equal to s dot, sorry, s dot size. Yes, it's s dot size. So here it is not string of s, it is instead vector of character, right? So we'll be referring it by, wait a second, referring, uh, so here vector of character. Okay, is there anything which we have missed? So instead of swapping, yes, we can also swap, I think. I think swap also works in vector of character, right? Let us see if it throws any error. Let us debug the code at that time. A recur of int I will be 0 as I said as the same n. Let me run the code. No, it hasn't swapped, right? If I is less than n minus 2, so it should be greater. Why? Because I will be from 0 and then 1 and then 2. If it is greater than 2, then we will stop it, right? So if I is greater than n by 2, then don't swap it. So that's why it hasn't executed it before, right? We got a wrong answer. So the one which is at this point, no. I think it should be greater than or equal to. Let us just change it, right? Sorry, wrong answer. Use test case. Yeah. So the wrong here is we are going even if it is equal to, right? Wait a second. What about this? Definitions. So what's the size here? Let us see. Uh, 1, 2. So 1, 2, 3, 4, 5, 6. We can just print it, right? See out size. No need of checking. See out and I. We can just print the size. Size is 30. Now 30 by 2 is 15. Now, okay. Uh, okay. That's the vector of character. Okay. So A 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, what is this? 12, 13, and mm, 13 and then 14. No, 30 by 2 is 15, right? If it is lesser than that means we are we are stopping here itself, right? So this hasn't even this was the problem. This was not swapped. That's why it has gave me a wrong answer, right? So we have successfully completed two problems today. So yes, today this recursion is. Wait a second. Let us see what's the next problem, right? So I think you have understood how we have solved it. There might be another things also. There might be other ways to solve this by using a big O of n also, but let us see. 1ms. So yes, by using the recursive code, we are going with the recursion, right? So it will be better if I do only by recursion. So I have just got with this because it will be got with this problem because it will better understandable if about the base case, understanding what will be the base case of a recursive code, right? So that's why I have chosen this problem to explain you, right? Okay, if you have any doubts, please let me know in the chat box. Okay, but can we solve this by only one line, right? Can we solve this by just one line? There is a standard template library to reverse any string, any data structure, right? Like a linear data structure, however, not trees and graphs. They can be reversed, right? We can only search in the tree and also graph. So the reverse function is the standard template library, right? So we can reverse it by using s dot begin comma s dot end. So it just reverses the given vector of characters. So no, not like that. We need to know about the recursion. But even if it is a standard template library, we should not use it when uh, it is like in a direct problem about uh, reversing a string, right? We can use it when we are solving a graph or a DP problem, but for this small problem, when they ask about the reversing a string, we should not just use the STL of reversing a string itself, right? So it will not be a better option. Now, let us go with the another problem, power of x comma n. So I'll be solving three problems and will be giving the three problems for practice. This is the problem which I have used for many hard problems, right? Power of x comma n. So this is the problem which we had even had used for hard problems and also medium problems, right? So it is better to go with the problem description first before going into how can we solve this, right? Okay. Let me know if you have any doubts regarding this session and anything about this DSA live streams. So we have given with x comma n, power of x comma n, right? Implement power of x comma n, which calculates x raised to the power n. That means x power n, right? Okay. Not just x squared or x cube. We can also get. Let us see what we can get. N can be even negative. Here we have also given with, okay, n can be even negative. Okay, power of x comma n. Let me tell you what is this. Problem link, leetcode, leetcode.com slash problem slash power x hyphen n description. Okay, I think you can access the problem. Let me know if you have any doubts, right? Lead code 50. Okay, I have posted I have given the link of the problem. Okay, 2 power 10. 2 power 10 is 1024. Okay, 2 power 5 is 32 and 32 twos are 1024, 1024. Now x is equal to 2.1. So we are given with double values. Now n is 3. So 2.1, 21 uh, cube is 9.26100. Now 2 negative, right? Let us see how can we get this negative values. So no need of, you know, going with the worrying about what if it is negative. If you see, 2 square is 4. 2 power 2 x power n is 4. Now 1 by 4 is 0.25, right? So what we need to do is just get the values and then do it like a 1 by that value. So I need to get the square or x power n value, even if it is negative. Don't care about negative, remove that negative value and get the value of x power n. Okay, x can be from minus 100 to 100, x power n, right? Okay, n is an integer, okay. Either x is not 0 or n is greater than 0. Either x is not 0, x cannot be 0 or n is greater than 0. Now x power n can be from minus 10 power 4 to 10 power 4. That means it is minus 10,000 to 10,000. The values which we can get. So the acceptance rate is also low, 37.7, right? That means like even lesser, like in 10, 4 only got accepted. In 10 submissions, 4 submissions was accepted. How can we solve this actually? Now, just imagine 2 multiplied for how many times? 10 times. That's what they are asking for. That's what we are asked for. Okay, we will use the recursion here, however, but let us see, can anyone give me any suggestion or any way to approach this problem, right? So if you have any thoughts about this problem, to multiply for 10 times, right? So we need to multiply the 2 for 10 times. What if it is not just 10? What if it is even greater value? So x power n, right? N can be 2 power 31 minus 1. What if he gave me like 2 power 31? Let me, it is like 2 7. Let me see. 2 power 31 is 21474832636448. Okay, this much bigger, right? So what if he had gave me this? It's a quite large number, but however, they can also give me this, but they can't because they said 2 power 31 minus 1. So 2147483 So 2 power 2147483 This can also be given in the problem. It is possible, right? So let us first suppose can also include that test case, right? 2.0 and then 21474483647 It is nothing but the maximum where integer can go. What I'll return, I'll just return 0. Let me just return 0 and let me do a run on this. Either x is not 0 or n. No, let us just give this 2147. No, it is even x and n, right? N can be a larger number, but however, it is not accepting that. Okay, let us not give 2 here, let us give 4 and then 0. Okay, yeah. Why? Because if you see 2 power all this will go out of the range of x power n. What they said us about the constraints, x power n will not go beyond 10,000. But I gave here x itself 2, so 2 power this will be much value. So 1 multiplied for how many times? Like infinite times will also be, also will even 1 itself. Okay, let us see actual int max value. Okay, we got it, right? So 1 itself. Let us see how can we solve this actually. Now, what is 2 power 5? I'll be coming with the code or the intuition, what I thought about it. First thing, what is 2 power 5? So 2 power 5 is nothing but 2 for 5 times. 2 into 2 into 2, 4 times and another one, 5 times. Now if you see here, 2 for 2 times is nothing but 2 square. 2 for 2 times is nothing but 2 square. This 1 time is 2, however. 2 power 1 is 2, however, right? Okay. Let us see another problem. 2 power 10. How can I write it? 2 power 5 into 2 power 5, right? I can write 2 power 10 as I am saying 2 power 5 into 2 power 5. How can I write the 2 power 5? 2 power 2 into 2 power 2 into 2. How can I write 2 power 5 again 2 power 2 into 2 power 2 into 2? What about 2 power 2? 2 power 1 into 2 power 1. 2 power 2 is 2 power 1 into 2 power 1. Here also 2 into 2 and here also 2 into 2. Okay. So what I am doing here, if you see here I got an even number. So 10 by 2 is 5, however. So I will calculate for 2 power 5. 2 power 5. But is there anything which I am missing? No. 2 power 5 into 2 power 5 is 2 power 10, of course. What about 2 power 5? That's the case here. That's the edge case here. 2 power 5 isn't enough. 5 by 2 is, however, 2, right? So 2 into 2 can give me, but 4 itself. So I need to add one more. For that, what I am doing, multiplying with 2 again. So if even power of, no, power is nothing but STL function x power. Let us just take that x power of 2 power n is nothing but here if you see 2 square, right? Let us see what is x and what is n. Okay, here we get x and here we get n. Now if n is 0, 2 power 0 is 1 itself, right? 2 power 0 is 1. What about 2 power 1? It is 2. So if n is equal to 0, return 1. Now if n is equal to 1, what we will be returning? What will be returning? 2 power 1 is 2 itself. So return x. But instead, if x is even, x power of x by x comma n by 2 into x power of x comma n by 2. Now if it is not even, then of course it is odd, right? So x power of x comma n by 2 into x power of x comma n by 2 into x again. So what I did actually, I didn't do any trick, right? So it's the same thing previously. Let me tell you. Let us do one thing. Let us do a dry run. That's the first dry run, right? So this will be the last problem for today. If x is even, okay, I wrote it already. First, let us go with 2 power 7. 2 power 7. I think it's clear for you. Now, let us not write like this. X power of what is x? X is 2 and n is 7. Is n is equal to 0? No. N is equal to 1? No. If x is even, this will be implemented, but not. It is not x even. It is odd. Sorry. If n is even, it is not x if n is even. So, okay. Sorry for the mistake. So n is even, then this will be implemented, right? But n is not even, it is odd. So what I need to implement? I need to implement x power of x comma n by 2. 7 by 2 is 3. Again, 7 by 2 is 3 into what I said into x. X is nothing but 2. Okay. This I have called for this and called for this, but after getting it, I'll multiply it with x, nothing but 2. Now, 2 comma 3. Here also I have, is n is equal to 0? No. N is equal to 1? No. Is n even? No. So else x comma n by 2. 3 by 2. What about 3 by 2? 1. X power of 2 comma 1. Again, x power of 2 comma 1 and multiply it with 2. Now, 2 comma 1, if n is equal to 1, return x. So, here it will call for x, here it will return what? X, right? So, here it will return 2. Here also, it will return 2. Now, what here? 2 itself, right? So, 2 into 2 into 2 is nothing but 8. So, the same thing here. The same thing will happen here. Right, here I got 8 and also x power 2 comma 3, the same thing. So 8. Now again, here I got 2. 8 into 8 is 8 8s are 64, 2s are 128. So 2 power 7 is nothing but 128. I think I am not wrong. 32 into 4 to see 8, 4 is 12. Yes. 2 power 5 is 32 and I am just multiplying it with 2 squared. So I got 32 into 4, which is nothing but 128. So that's all for today's session and we'll be having another session tomorrow. But we haven't even implemented it, right? So let us implement this. So why we should do this all x power and all right, we can just call the same function, right? So if n is equal to 0, return 1. If n is equal to 1, return x. If n mod mod 2 is equal to 0, that means it is even. So we will call for my power of x comma n by 2, sorry, n by 2 into x n by 2, else my power of x comma n by 2, sorry, else no need of this, we can just copy it x comma n by 2 and we'll just multiply it with x again. So x comma n by 2 and all. Is there anything which we have to return? No, we just call and return. Yes, at the last return 0 so that it won't give me any runtime error. No, return my power of, sorry, it is my power, right? Let me run this again. No, time limit exceeded, right? So if x is 1, we need to return 1, x is equal to 1, return 1 there itself. But the recursion stack might give me a TLE, right? We can, let me do one thing. I'm just copying this and pasting it over here. But before that, double uh, x, no, x power. Let's take that x power of int x, sorry, double double x int n, right? So this is the code, but x power, right? We need to take x power the x power. So if n is lesser than 0, let us see. Flag, I'm just saying that flag is equal to false, sorry, true, neg. So bool neg is equal to false. Now if n is lesser than 0, negative is made as true. Now double value is equal to x power of x comma n. I got the value. But if negative, then return negative of value. But n should be made as minus n. If not, return value. I'm running it. We got a wrong answer. So, not negative value. We need to return 1 by that value. I need to change it to double also. Let us see. I'm just submitting with a double this typecasting. No, x power. So, so this is giving me a wrong answer. TLE, right? I think there will be, if n is equal to 0, it will be 1. However, okay. I think we need to use a DP here. I don't know whether the recursion code runs right. Power of x command. We can solve this by using a STL, but we don't choose it. Instead, we can do it by a recursion, however. I think if anyone knows how we are getting a wrong answer, nothing but ATL, right? Let me know in the live chat. Okay, it will return, however, in double, right? Let us take this as half. We need to return it, right? So, half value. What is about half value is nothing but this one. Now, we'll just return half value into half value. Control C into, okay, we're just multiplying it, half value into half value. I think we don't need to return any zero. Half value is equal to x power of all this. If x is equal to 1, we'll be doing it. Okay, I think it runs. Yes, let me submit the code. Minus n, okay. Let us take long log nu n is equal to n, nu n is equal to minus n. Is there anything which we have to do, right? I think nothing. Minus n. Log nu n is equal to n. Okay. Nu n is equal to minus n. We can just return nu n. So here I need to change it from int to long. So we are sending new n, right? Let me also take this. No. New n is equal to minus n. New n is equal to n. New n is equal to minus new n. So here we used n instead of new n. Let me run the code. Okay. Have we used this test case? Okay. Yes, we have used the test case. Let me submit the code. Okay. So that's all for today. If you have any doubts, please let me know in the live chat. We'll be extending this session for 15 more minutes. Okay, let me write it so that no one confused. Okay, right. Hi, brother Bhaskar. Hi, how are you doing? Right. Okay. So let me know in the live chat, can we have any interaction? So let us be clear that we'll be having these sessions, but okay, right. How to start DSM? So, bro, I have also given you in my Instagram that I have shared the link, right? So, I have shared the roadmap to DSA. So, you can follow me there, or you can go with, what? How does this Instagram looks like? However, underscore R underscore S underscore 11. This is my Insta one, however. So here you will be getting the updates, and also in YouTube, maximum of the updates you will get in YouTube, however. So this is my Instagram profile. You can follow me there. And in LinkedIn, that's the important thing, right? In LinkedIn, you can follow me. I'll provide you with the profile name R Sai Sidhu. R Sai Sidhu, right? You can follow me there. Is there anything? No. I think it's clear, right? I have given the, you know, what do you say that? The roadmap to DSA. Roadmap to DSA in both the Instagram and also in LinkedIn. So in also GitHub, you can follow me in GitHub. I'm not so active in GitHub, however. Okay, thank you. Okay, thanks, brother, for attending this live session. So let me know how you feel about this live session, right? So you can comment your suggestions, and also if you want to share your if you want to ask any doubts, yes, you can just comment in the live chat. You can go to the description of this video. You can get all of those, Fiverr, uh, you know, this freelancer account of Fiverr. And if you want TopMate, so the link I have provided, right? Topmate.io. So there will be free one-on-one session in TopMate. So there will be like a 10-minute session, or we can also extend it on your based on your requirements. But TopMate, TopMate, let me type it. Okay, I think the page is missing in the description. topmate.io/r_sci_sit. Right, this is my topmate profile. So you can just join me in the free one-on-one doubt session. Right, it will be a helpful session if you have asked me any questions, but if not, it will be just a time pass one. Right, okay. We'll be ending this session soon in 5 more minutes. So if you have any doubts, let me know in the chat box. I have given the topmate free one-on-one doubt session, right? So you can follow me there, and also I have given you the link to the the profile name rsaisiddhu and also Instagram ID, right? So we'll be ending this session at 6:40 sharp, right? YouTube is not receiving. Excuse me. At 6:40 sharp, we'll be ending our live session, right? So if you have any doubts, please let me know in the chat box. Yes, if anyone is new to our channel, this is A to Z DSA course, right? Starting from the beginning. So today it's about recursion, and we have discussed about recursion. And if anyone is having any doubts, let me know in the chat box, right? So you can ask your doubts here, and I have given you if you are hesitating to ask in this session, you can follow me in TopMate, and also in Instagram I have given you the DSA roadmap. However, you can go and check it. Okay. Okay, right. So we'll be ending this session at 6:40 p.m. exactly. If you have any doubts, please let me know in the comment section. So this is the doubt session. So we'll be ending this in 2 minutes, however. So if you have any doubts or you feel hesitate or you want to ask me personally, you can ask me in free one-on-one doubt session at talkmate.io/r underscore psi underscore siddh, right? And I have given the DSA roadmap, complete roadmap in my Insta profile. So the profile, uh, you know, username is r underscore s underscore 11. So you can follow me there, and I have pinned the roadmap. That post, I have pinned that post. So let me know if you have any doubts, right? So I think there might be someone who has been starting DSA and will be, you know, finding it hard to solve the recursion problems. So if anyone is facing those problems of solving recursion and also not able to find the logic and also how can we go through the thought process of the intuition, please let me know. Any doubt about the data structures and algorithms, right? You can ask me in the comment section. We'll be ending this in 5 minutes. Yes, we'll be ending this at 6:45 sharp. We'll be ending this session in 3 more minutes, right? If you have any doubts, let me know in the live chat. Okay. We'll be ending this session in 1 more minute at 6:45 sharp. Right, if you have any doubts, please let me know in the chat box. So if anyone is new to our channel, we have discussed recursion and also discussed three problems, and I'll be giving you three problems for practice, right? At the end, have I'll be mentioning in the next post in YouTube, right? So you can just check those three problems. And this is about the doubts session. So in one more minute, we'll be ending this doubt session and winding up this live, right? Okay. Daily we'll be having DSA content in our YouTube channel, right? So starting from the beginning, this DSA course will be from arrays to dynamic program. So if you have any doubts, please let me know. I have given all of this, right, doubt session, and also given the free one-on-one doubt session link. And also DSA roadmap was posted in my, uh, you know, Instagram profile. And also the LinkedIn profile is rsaisiddhu. That's it, the profile is rsaisiddhu. So if you have any doubts, please go there and just let me know your doubts. Right. So we'll be ending this session now. So thanks for attending this live. So thank you.